Since today everyone is here, so I just want to keep everyone on the same page for the rest of how many weeks? 2 weeks for the semester, this week and next week, before the final exam. We have one tutorial left, the SPI. Since I know it's unrealistic to add a lot of tasks to you guys, given that we still have a project to work on. So this one, just to let you guys, try it, play with it, and no new tasks. The 2 tasks is just repeating whatever I have done here. I think what you need to do is find these modules and put them together, modify the constraint file, compile it, and make it work. Should be done in a couple hours, I think. So you can spend most of the time on the project. And we do need you guys to form teams. I don't know, like 2 people on one team, probably. If you haven't done that, please, find a teammate as soon as possible. So that is for the project, okay? And you do need a report for the project and also the presentation. Did I specify when is the presentation? Is that, I think it's going to be the Thursday here during the lecture time. We cannot do it during the lab time because we have 2 different sessions. So we are going to do it on the 5th here for the presentation, and the report I think will be due by the end of next week. It's a lot of work since I know some of the scripts are pretty large scale. It takes a lot of time to compile and synthesize. This is the first time we are doing this, so we'll see how that goes. I don't know yet. I mean, just let me know what you can do here. So these are all the tasks for the project. Okay, you can pick up either one you want. If you need a joystick, you can get one from me. Okay, for the second one. The first one just converting HDL to Verilog. I think it works pretty well. I mean, and also change the graphics over here. Okay, that's for the project, and then we have a final exam. I'll give you examples and what I'm expecting to put on exam. I think by the end of this week, so you would be able to know what are going to be an exam and prepare accordingly. Okay, that's a Monday exam, right? You have 1 homework assignment left and 1 teaching evaluation left, which is another assignment. Anything else? I have given you the light sensor. So what's the difference between this light sensor and also the LDR, the light dependent resistor? You may have used in circuit 1 or probably not. But have you seen that LDR somewhere in microcontrollers, right? Why do we bother, having this fancy PCB instead of just use a low-cost resistor? What's the difference? Precision, yes. So this one can give you more values. It's being digitized. But the resistor is only changing the resistance that continues in the analog range. Have to form a voltage divider first, and you probe that voltage change using ADC. But this one already has ADC inside, so what you are getting is exactly a digital signal. So it's actually converting the light data into digital data in the form of a protocol which is called SPI. So we're going to take a look at it today. We have used SPI in microcontrollers, so we do have SPI modules on our Arduino chip. So the advantage of using SPI over UART, UART has only 2 pins, RX-TX. It doesn't even have a clock because you specify the baud rate in the digital module already. either 9600 or something else, right? So they know each other, like what is the transmission rate for the two modules. But here you have a dedicated clock and you have two pins. So there are more modules. And one very significant advantage of this one over UART is you don't have to use 1 byte for transmission all the time. You can specify the length of the data on your own because so many digital systems are using 16 bits or 32 bits, even 64 bits. If you use UART, it's always 8 bit. It's sending 1 byte by 1 byte. But in SPI, you can change it manually, whatever you want to do. Okay, you can modify it in the software. Okay, and by looking at this diagram over here, so MOSI is a master out, slave in, right? So the textbook is trying to not using master and slave. It's trying to use leader and follower. I just need to know these are the same. What is a leader? Leader is the master here, right? So follower is a slave over here. So MOSI, which means just behind that pin, inside the master or leader, it must have a module here to control it. So it's outputting data. How many bits are in that line, you think? So this single line, how many bits? 1. It's a serial, right? So 1, clock is 1. This is a chip selection, just 1 pin, high or low. So 0 active, which means if you send a 0 from the leader, it's going to activate the follower. So it's going to do a chip selection. So it's going to enable this follower. And clock, just the clock. So MOSI, so the master side is outputting signal to the slave side. So that's why it's when master is outputting, the slave is inputting. So it's MO and ISI, right? And on the other side, it's MISO because slave is outputting and master is inputting. So you need how many modules for how many different Verilog scripts for these two? 4, right? So output or transmitter for master, transmitter for slave. So where is the transmitter for slave? You want to program in. SO, right? Slave out. So that's a transmitter for slave. You need a digital module here. And also you need a master in, master receiver, and a slave receiver. So here's a master receiver, it's MI, right? Master receiver, master input, and slave receiver, which is SI here. So you need 4 modules. So the textbook introduces the 4 modules in detail, and here's a PDF. You can refer to that, and if you have a textbook, which will be even better, read through all these scripts and understand it. Based on what we have done in the past, this is not difficult. And we are using a light sensor like I just talked about at the very beginning. So the light sensor sends the light, the ambient light, and send it to the IPGA board, which is considered as the master or leader. So quick question over here. Which device do you need to program? Just for this application, we're not doing anything else, only 2 weeks left. What can I do, right? So which one do you need to program? Can you program the sensor? Why? So what is on the sensor? The light sensor and maybe SPI module. So who did according to here, what is on the slave? So sensor is the slave, yeah, the follower, right? So what is on it? So a company who made these sensors, they hired digital design engineers like you guys, come over and make the sensor for me. So what is being synthesized, implemented, fabricated on the sensor? Which module? No, I mean for the four modules, for the four logic modules, which one? So if I have to let you draw the diagram of the light sensor or the sensor here, right? What do you need? First, a light sensor. What is a light sensor? It can be a photodiode. Okay, it's a semiconductor material, right? It receives light and convert it into current or voltage. Usually current. It's a photo effect, right? Einstein won that Nobel Prize 80 years ago for that. Right? Current, so photons can be converted into photocurrent. And photocurrent being converted into voltage. Is that analog or digital? Analog. So we need an ADC. Okay, so to use the ADC to digitize it, so we got a digital signal parallel, for example, A bit. Outside of the ADC, A bit. What's next? You got a data ready, it's a byte, for example. I know it's not a byte, but the byte is ready over there. What's next? Parallel to serial converter. And actually it's an SPI module. So which SPI module is being used for the digital designer design that chip in the company? Which one? Which one was implemented? MOSI, MISO, MOSI, MISO, which one? It's a transmitter for the follower, right? It doesn't need to receive anything. It's just outputting something. It's a light sensor, it's reporting or sending the digital data out. So you need a MISO, which is master in, slave out. But actually, it's just one of the four modules. It is a transmitter for the slave or the follower to be implemented in the sensor. You don't need two of them. You just need one. You just need the transmitter for the follower. Okay. So the A-bit parallel data will be converted into serial data in the SPI protocol and being sent out to a master, whatever you are using. A quick question here. Can you use Arduino to interface with this sensor? Can you use Arduino to interface with it? Come on, definitely. Arduino has SPI. Let's just connect. I mean, if you can open up the pinout of the Arduino chip, you can see MISO, MOSI, CK, CS, right? Sometimes SS, CS. It's just chip selection. So just hook these four pins to the sensor and use whatever SPI package you can find online. You know, it's just a function, and you can define the speed of the SPI and the data length of the SPI. So just program it. So your Arduino chip will be able to receive data from this exactly the same sensor, and you can visualize it in a serial monitor. You can report it to somewhere else. You can send it wirelessly to somewhere else. It's going to work. It's a standard SPI module. Why do we need a protocol? Because the standard timing diagram is everywhere. Whenever it's called SPI, it's going to be the same, exactly the same. So if you have SPI module on that CPU or the SoC, system on chip, you can definitely use it for this purpose. But do we have an SPI module in our FPGA chip? Basis 3 board. Do we have an SPI over there? No, it's blank. It's just all these individual gates, right? Or lookup tables. If you don't program it, it's nothing. There are no connections. There are just lookup tables and gates. Okay, so you program it, synthesize it, implement it onto your FPGA chip. You are able to generate an SPI module, and which module you want to use, which one you should use for this application. Which module for the four? For four here, which one you are going to use? MISO or MOSI or here? Which one should be implemented? MISO, because the SPI module in the IPGA is only receiving data, light data from the sensor. And do we need to talk? Do we need to send something to the sensor? No, just receive. So the ICK is a clock. So the light data will be converted into SPI protocol and being sent to the master through the MISO pin. It's the same pin, it's the same wire. You connect the two pins of the master and slave together, just use one wire. But however, they do have different scripts inside, and you do not need to program or modify the module script on the sensor, and you cannot. It's already a hardware. It's designed by the engineer of the company. But what you can do is you have to, because the business report doesn't have that module. You have to program it, which is going to be a receiver. The licensor module is going to send data to the business report, which performs as a receiver, and also it's a master. So you need a receiver module for the master. On the textbook, the formal name for that is, there are 4 scripts, right? Receiver for the master, transmitter for the master, receiver for the follower, transmitter for the follower, okay? So now we just need to use one of them. The one I want to use for the master or for the business report would be the receiver for the leader. That's the one you want to use. That's why you are seeing here. These are the modules. SPI light sensor is the top module. I just name it in that way. You can name it a different way. And you can see it's the SPI leader receiver. Okay, as a leader, as a master's receiver, receives data from the light sensor module. And definitely you need some peripherals, the bandwidth to BCD, 7-segment display. So the PDF explains what is in here. The 7-segment display driver and just a conversion, decoder, and you don't need to wire everything up because these sensors were from the same company, the Vigilant company, which fabricated or designed these business reports. These pins on the board, IPGA board, you can directly use them. Just plug that sensor into the board over here, to these specific pins over here, and you can directly use them. You need some modification to the constraint file, and also make sure that the sensor, light sensor, which is this single chip, should face up, okay? And you can use a flashlight or can use something else to change the ambient light intensity. And I just used a super bright flashlight, which saturates sensor really quickly if I turn it on. So you can see it's 255. You know, it's showing 254, but you can imagine that it's an 8-bit. It's an 8-bit sensor. So 0 to 255. So 256 levels. Okay. Very straightforward. Practice this a little bit. So I got some experience with SPI. I mean, if you are looking for jobs in a digital design engineer, I recommend you to, play with the 4 modules, so you can put it on a resume, as one of the items, one of the entries. So you have a bigger entry on the top, IPGA design or system level design, and I have several bullet points, familiar with SPI protocol, just something like that. Looks good on your resume. Any questions? You have to spend time on reading these lines and try to understand it, okay? Which will probably be the most time-consuming part of it. But other than that, I think it's straightforward. Just do copy and paste, modify a little bit, and demonstrate it. Okay.